Good morning, I'm Karam from CCS Graduate School of Mobility at KAIST. Today, I will be presenting my research on measuring mobility vulnerability on a continuous scale. The main focus of my thesis is to understand how this continuous measure of vulnerability affects railway station users. Specifically, I investigate two questions. Does it make people take longer to reach the platform? And does it decrease their overall satisfaction with the experience? Here's the outline. I will start with the background and objectives, then the theoretical framework, survey design and method, three sets of results, and finally, conclusions and policy implications. Let's start with the introduction. This study is motivated by two social contexts. The first, transport access is a social equity issue. Limited mobility access leads to exclusion from education, employment, and healthcare. Railway station place a heavy burden on constrained users, vertical movement, long walks, complex layout. Second, South Korea is aging fast. The country just entered a super-aged society. About a third of the population has some form of mobility limitation. Elevator installation rate have met legal standards, but the actual experience has not improved. Meeting compliance targets and improving user experience are two different things. Why not? The problem is how we have been measuring mobility vulnerability. Prior studies treated it as binary, elderly or not, disabled or not. But within the elderly group alone, some people move easily while others struggle. A yes or no label cannot capture that. Few studies have estimated how vulnerability affects both travel time and satisfaction simultaneously. This gap is what this study addresses. The central goal of this study is shown at the top of this slide. To measure mobility vulnerability on a continuous scale and identify its effect on travel time and satisfaction among railway station users. The first measurement, extract vulnerability as a continuous score from 5 items using exploratory factor analysis. Measuring it as a spectrum rather than a binary is the core methodological choice of this study. And second, travel time. Estimate how that score affects in-station travel time using the accelerate failure time model. And third, satisfaction. Estimate how vulnerability and travel time affect satisfaction using the Ordered Logit model. And fourth, policy. Derive policy implications from these findings. You will notice the yellow stickers in each box. These reappear throughout the presentation, so you can always tell which objective is being addressed. Now let's look at the theoretical background. The three boxes here map directly onto the three objectives. The definition at the top, vulnerability is what users actually feel, not what a checklist says should work. The first box, vulnerability is not a fixed trait. It depends on the person, the environment, and the situation. Heavy luggage, a confusing layout, an unfamiliar app, any of these can push someone toward constraint. This study measures that as a continuous score through EFA. And second box, does higher vulnerability delay travel time? Constrained users take longer, not just because they move slower, but because they search for elevator, wait, and avoid crowds. The AFT model estimates exactly how much. And third box, vulnerability reduces satisfaction. And not just because it slows people down. Even when travel time is the same, anxiety and fatigue users rate the experience lower. This study estimates both effects separately. With that theoretical base in place, let me now explain how the data was collected. The survey was conducted in January 2026. Adults aged 20 to 79 who had used railway services within the past 6 months. Gender balanced with proportional age allocation. One key design choice, intentionally oversampled adults 65 and above to about a third of the sample. A natural sampling rate would not give us enough data for this group. Key measurement areas, vulnerability perception, digital capability, situational constraints, perceived travel time, and satisfaction. A few patterns before the model. If you look at the bar chart on the left, the average travel time was 6.65 minutes, but some passengers took much longer. If you look at the table at the bottom, luggage weight shows the biggest gap, over 2.5 minutes difference. Physical mobility and digital literacy also matter, but less so. If you look at the chart on the right, satisfaction scores are around the midpoint. Interestingly, older adults rate slightly higher than average. This hints that age alone may not drive dissatisfaction. Now let's look at the analytical method. The flow works like this. Survey data enters in two forms. On the left side, 5 physical barrier perception items. On the right side, personal variables, age, luggage load, how much luggage the person was carrying, and device count, the number of assistive devices used, and app proficiency, how comfortable users are with smartphone navigation apps. The key steps is exploratory factor analysis. 5 perception items go in, and what comes out is FA total, a single continuous vulnerability score. This is objective 1. FA total then fills into 2 models, the AFT model, objective 2, and Ordered Logit model, objective 3. And both feed into policy implication, objective 4. These 2 models are not a pipeline. They share FA total as input, but are estimated separately. To summarize the variable structure quickly, 3 tables, 1 per objective. On the left, the EFA input, Q10 through Q14, are going into FA total. That score then feeds into the 2 models on the right. The middle table is the AFT model, where FA total projects travel time alongside FA total. We also control for app proficiency, luggage load, age, device count, and station type. And on the right, the Ordered Logit, where FA total and travel time together predict overall service satisfaction. The same control variables are included here as well. FA total is extracted on the left, then feeds directly into both models. The measurement step makes everything else possible. Now for the result, I will go through 3 analyses in order. Let's start with the EFA result. This is where objective 1 gets answered. All 5 items loaded onto a single factor, KMO well above the threshold, explaining about half the variance. Looking at the loading from top to bottom, the strongest is long-distance walking difficulty, followed by companion need, stair difficulty, visual and hearing discomfort, and companion burden. The core of vulnerability is whether a person can navigate the station independently. That is the first contribution. Vulnerability does not have to be a yes or no category. It can be measured as a single continuous score, FA total. Moving on to the AFT model, objective 2. The key finding is that higher vulnerability means longer travel time, and the effect is strong and significant. If you look at the FA total, what delays travel time is not age. After controlling for FA total, age alone has no independent effect. In fact, older respondents were slightly faster. They tend to plan ahead, avoid peak hours, and know their stations well. The point is that age and vulnerability are not the same thing. Vulnerability is what actually drives the delay. And station type also matters. Seoul and Busan showed substantially longer travel time than general station. Complex layouts create structural barrier regardless of who is using them. Luggage and device count also extended travel time significantly. And app proficiency, by contrast, it has no meaningful effect on travel time. And finally, the Ordered Logit, the travel time, longer time in the station, lower satisfaction, holds after controlling for everything else. And FA total, vulnerability reduces satisfaction independently, even after travel time is in the model. Anxiety, fatigue, and the feeling of needing help, these lower satisfaction on their own. Fixing facilities addresses the delay. It does not address this. And app proficiency, the strongest predictor of satisfaction in the entire model. But back in the AFT model, no effect on travel time. It does not make people faster. It reduces uncertainty. People know where they are going, and that changes the experience. Luggage load and age, no significant effect on satisfaction. Users observe these as personal problems, not station problems. Now let me place both models side by side. Again, these are independent estimations sharing FA total as input, not a sequential chain. A few clear patterns stand out. FA total matters in both travel time and satisfaction, the central variable. Luggage load and device count delay travel time but have no effect on satisfaction. Users treat this as their own problem. The station never gets the feedback. At proficiency, no effect on travel time, strong lift in satisfaction. Information matters more than speed. And age, slightly faster travel time, marginally higher satisfaction after controlling for vulnerability. The constraint matters, not the age. Let me wrap up with the conclusion and policy implications. Here are the 4 key takeaways. First, vulnerability is measurable as a continuous variable. EFA produced a stable single-factor solution. No binary categories needed. Second, vulnerability, not age, drives travel time delay. After controlling for vulnerability, age had no independent effect. Using age as a policy proxy is empirically limited. Third, vulnerability lowers satisfaction, directly and via travel time. Physical improvement address the delay. They do not address anxiety and fatigue. Both need separate interventions. Fourth, digital information matters more than physical access. Proficiency was the strongest predictor of satisfaction, stronger than any physical variable. Based on these findings, I'd like to propose 5 policy directions. First, shift from age-based to vulnerability-based criteria. Support should reflect actual mobility constraint level, not just age. Second, prioritize physical improvements at large hub stations, where travel time delays exceed 25% compared to general station. Third, physical upgrades alone are not enough. Vulnerability reduces satisfaction directly beyond travel time. That means anxiety and fatigue need to be addressed as a separate target. Clear wayfinding, on-site assistance staff, and reassurance services are the tools here. Fourth, invest in digital information services. Smartphone app ability was the strongest predictor of satisfaction in this study, stronger than any physical variable. Indoor navigation, kiosk UI improvement, and digital guidance are highly priority investment. Fifth, reframe luggage and assistive device inconveniences as a station responsibility, not a personal problem. Right now, users observe this as their own issue, which means the station never gets the feedback issued. Dedicated routes, luggage storage, and on-site support can close the gap. Let me summarize the key findings and limitations. First, vulnerability is not one-dimensional. It's physical, sensory, and social, captured as a single continuous score. Second, we analyzed travel time and satisfaction together. We found that vulnerability directly lowers satisfaction. This means we need both physical and psychological support. However, there are some limitations. First, travel time was self-reported. Future studies should use GPS. Second, the satisfaction model fit is low. We need more variables. And third, because of cross-sectional data, we need longitudinal studies in the future. Finally, please look at the bottom of the slide. This analytical framework is very flexible. It can be applied to other transport modes and environments. That concludes my presentation. Thank you very much.